Hi, my name is Candy Peng. Today I'm going to talk to you about what do programmers know about software energy consumption. My research team and I have done a survey on this topic. The survey result has been published in the May and June 2016 issue of IEEE Software magazine. Well, why do we care about software energy consumption? First, we care about it because of mobile device. Mobile devices has become part of our life. With better software energy efficiency, our mobile device can last longer. Second is about data center. Each data center have a limited electricity supply. That means it limits the number of machines that a data center can run and cool. In addition, it's about electricity costs. It's estimated for each dollar worth of hardware, the data center needs to spend additional 50 cents on power to run and cool the machine. Software energy efficiency largely depends on the programmer who wrote those software. Therefore, we are interested to know whether programmers are aware of software energy consumption. What do programmers know about how to reduce software energy consumption? What is the level of knowledge programmers have about energy consumption? And also, what do programmers think that causes high energy consumption? To answer our questions, we want to survey programmers. Therefore, we post our surveys in 7 different programming-related Reddit sites. At the end, we received 122 surveys response, and then we have 4 follow-up interviews. There were 4 groups of questions in the survey. The first group of questions asked for programmers' demographic information. The second group of questions asked programmers to rank computer components according to their software energy consumption. The third group of yes-no questions will show us respondents' awareness in software energy consumption. Lastly, the open text questions let programmers show us how much they know about software energy consumption. This is a sample of the survey. We try to keep it short and precise. From the demographic information, we know that more than 3/4 of the respondents were programmers with experience more than 3 years. In addition, only a few of them were in the beginner levels. The rest of the respondents were in the intermediate or advanced level. These are the programming languages used by our respondents. We are glad that this distribution is matching the IEEE index regarding programming language in general. In addition, a later survey showed that 67% of cloud programmers are using Java, and we have quite a few Java programmers in our surveys. We have faced certain limitations during our survey. First, we are using social media to recruit people for our surveys. In the social media, there were people with really strong opinion on certain subjects. Secondly, we need to be careful about the length of the surveys. Most people don't like to answer lengthy surveys, so we have to keep it short and precise. Because of that, we might have missed some important questions. For example, type of programs they are creating, what role they are in, or in what domain they are working on. Also, we have to focus ourselves on software energy consumption. At the end, we may neglecting other non-functional requirements such as performance, security, and usability. A lot of time, software performance may be confused with software energy efficiency. For example, a programmer may use parallel programming to improve software performance. However, parallel programming may actually increase software energy consumption. Our first finding is that programmers have limited awareness of software energy consumption. When asked whether they take power consumption into account when developing software, 82% say no. Then further, when asked whether minimizing power consumption a requirement or a concern when they develop the software, 86% say no. One interviewee indicated that clients care first and foremost about speed of development, and secondly about reasonable quality and performance. This suggests that the lack of attention to software energy consumption is an issue of priorities. Then we asked the programmers whether they have modified their software to reduce power consumption. 79% say no. In addition, we asked whether their user complained about their software power consumption. 97% say no. Actually, this result confirmed another research saying that mobile application users were not aware of the resource used by the device. If customers and clients are not asking for energy efficient software, programmers were less likely to address the energy efficiency of the software. Our second finding is that programmers lack knowledge about how to reduce software energy consumption. Programmers cannot reduce software energy consumption without measuring it. Therefore, we asked them whether they measure their software's power consumption, and 90% say no. Amongst those who actually measure, we asked them how do they make the measurement. From the results here, you can see that the top three results is power meter, battery, and power supply. Actually, power meter and power supply measure the energy consumption of the whole device, but not the software itself. Battery is not a reliable way to measure energy consumption because batteries do not accurately report energy level. However, when we ask the programmer whether power consumption is one of the decision factors when choosing a mobile development platform, 65% say yes. So it is likely that programmers relied on the platform to handle software energy efficiency. To find out exactly what programmers know about reducing software energy consumption, we asked in an open text question how would they improve their software power efficiency. Their result is shown here. The suggestion including better algorithm, less computation, improved network access, better I/O access, sleep, improved graphic handling, avoid pull or post, test and improve caching, and there were some other less popular suggestions like better hardware, improved multi-threading, task bundling, avoid sensor, less user interaction, parallelism, virtualization, and use native code. Some of the suggestions might not be very correct. For example, using better hardware to improve software energy consumption may be a challenge. No matter what, even the most popular suggestion, better algorithm, we received this suggestion only from 19 respondents among 122 respondents. That means most of the participants or programmers have no idea at all about how to reduce software energy consumption. Our third finding is that programmers lack knowledge of software energy consumption. We asked the programmer to rank for desktop computer and then for mobile device how software power consumption on different components. This is our expecting ranking for desktop computer and for mobile device. This ranking was based on current conventional wisdom backed up by experience we have performed over the past 3 years and recent studies. The respondent ranking for desktop computer is shown in this chart. The legend on the side shows our expected ranking. If the respondent ranking match our expected ranking, you should see the first bar to be the tallest in the first group, the second bar to be the tallest in the second group, the third bar to be the tallest in the third group, so on and so forth. However, from the chart, you can see that the responding ranking is very different from our expected ranking. Actually, only one respondent has ranked the component according to our expected ranking. This chart here shows the respondent ranking for mobile device. Our expected ranking is also shown in the legend. From this chart here, you can see that the first bar is tallest in the first group, second bar is still quite high in the second group, and third bar is relatively high in the third group, so on and so forth. That means respondents agree more with our expected ranking in mobile device. An interesting observation is that in both desktop computer and mobile device, respondents overwhelmingly rank the screen and GPU as the highest energy consumption component. In that case, programmer may be ranking the component according to what they can actually observe. Energy consumption can differ among specific hardware. Therefore, instead of comparing respondents' ranking with our expected ranking, we use Spearman's rank correlation to compare the respondent rankings against each other. The result is shown here. For desktop computer, the Spearman rank correlation is 0.3, with standard deviation 0.48. These results mean that the respondents were considerably disagreeing with each other about which component were using more energy. For mobile device, the Spearman's rank correlation is 0.6, with standard deviation 0.32. Comparing the result with desktop, that means the respondents were more agreeable about which component used more energy for mobile device than desktop computer. Yes. Our fourth finding is that programmers were unaware how software consumes energy. Software consumes energy in many ways. Therefore, we asked programmers to list in an open text question the software functions that have high power consumption. The provided answers were listed below. That include graphic, computation, network, media access, pulling or polling, sensor, back algorithm, and a few others. From the result, you can see that most respondents don't have much idea about what software function cause high power consumption. Although most of our respondents don't know what software function have high energy consumption, together they come up with a comprehensive list. For example, Puno and his team have identified 7 causes of unnecessary software energy consumption here, including unnecessary resource use, faulty GPS behavior, background activities, excessive synchronization, background wallpapers, advertisements, and high GPU usage. Compared with the response from our respondent, their answer actually almost complete the list. Based on our findings, what can we do now? First, we need to increase user awareness. No one likes to see the battery low sign on the device. Therefore, we propose having an Energy Star rating for software. In that case, user can select the application according to the Energy Star rating. Then we need to start measuring the actual software energy consumption. As mentioned before, it's not easy to measure software energy consumption. Therefore, it would be nice to have energy measurement centers set up around the world with the proper device and software that can measure software energy consumption. In that case, programmer can send the software to these centers for measurement and certification. It can also avoid situation in the car industry where individual vendors flick the measurement, like Volkswagen or Mississippi. Furthermore, we need to motivate programmers to enhance software's energy efficiency for sustainability. Most of the data center charge the users by disk space, CPU, memory, and network. What if energy efficiency is part of the building equation? In that case, when programmers design the application, they will need to consider whether the application is energy effective, and they need to balance the features with the cost. In addition, we can create tools to help programmers. For example, we can create source code analyzing tools that create energy efficient suggestions. In addition, software can also compare energy efficiency between different versions to identify specific energy defects. Finally, we need to educate programmers. Pintos and his team identified 8 strategies to reduce software energy consumption, including minimizing I/O, bulk operations, avoid polling, hardware coordination, concurrent programming, lazy initialization, race to idle, efficient data structure. We can teach programmers about energy efficiency through education, textbook, or mock. In conclusion, we have these 4 findings from our survey. Number 1, programmers have limited awareness of software energy consumption. Number 2, programmers lack knowledge of reducing software energy consumption. Number 3, programmers lack knowledge of software energy consumption. Number 4, programmers are unaware of software energy consumption's costs. These are the references used in our paper. The Green Software Survey results and findings were published in the May and June 2016 issue of IEEE Software magazine. If you are interested in the actual survey data, you can find the data from this link. Thank you very much for your time.